if you're trying to sketch the graph of y equals 1/2 cosine x, just a real quick primer on cosine and sine graphs. Cosine x, when it's just by itself, it starts at the peak of its amplitude. It starts at 1, goes down to -1, and then comes back within 2 pi. So what that means is because it, well, I guess the best way to say is the horizontal axis. If you find like the middle ground, at the y equals 0, the graph is right in the middle of the y-axis, right? It goes between -1 and +1, basically. So that means it has an amplitude of 1 because it goes up a distance of 1 from that center point on the y-axis, okay? So that's an amplitude of 1. That's how high or how low it goes. And then the period of a function is how long it takes until the function starts repeating itself. Cosine and sine, when they're left alone, when we don't do any funny business, they have a period of 2 pi. So this is a graph of cosine, okay, not sine. But they said it's 1/2 cosine x. So what the 1/2 does is it changes the amplitude. If you multiply 1/2 to the outside of cosine x, that changes the amplitude from being 1 to being 1/2. So when I sketch this graph, I'm going to start halfway up between 0 and 1. I'm going to go down to halfway down between 0 and -1, and then repeat myself. So at 2 pi, we should be repeating ourselves. So when you graph this in Alex, what you have to do is make some points. So here's that 1/2 on the y-axis that we said. And then it's going to go down to -1 on the y-axis. Let's see here. That's when it should be halfway through the loop. So that should be at pi. And then it comes back to +1/2 after a certain amount of loops, okay? This piece right here, this is pi, okay? Because you're halfway through the period. You're halfway to the point of repeating yourself. And then it'll just keep going like that. So to draw the graph, plot all the points corresponding to the X-Intercepts. So that's where it crosses the x-axis, okay? So to find an X-intercept of a function, that means you need to plug in 0 in for y. Okay, so to find an X-intercept, you plug in 0 in for y, and then you got to solve this equation. So one thing you could do is multiply both sides by 2. That makes this 1/2 cancel out. And then to finish solving this equation, you need to know just a little bit about cosine of x. The way I usually show students is that cosine is the x-coordinates on the unit circle. So if you need cosine to be 0, it happens in 2 different places, okay? Cosine is 0 right here. If you were to draw an angle right here, that's a 90-degree angle, or in radians, that's pi over 2. Okay, so pi over 2 is where this thing should cross the x-axis, and that looks about right with our graph. If pi is where it's down here at the valley, then about halfway, pi over 2, halfway between pi and the start, should be where it crosses the x-axis. So we're going to put a dot at pi over 2. That's the x-intercept that this graph's talking about. Okay. The minima and maxima means like the highest point. So that's this highest point that we already graphed. That's the maxima. And then the local minimum we have is right here. Okay, like the lowest point it gets on an interval. And then click on the graph icon. So I think we click this. 5 points. Okay, so we could get another point. Oh yeah, because it also crosses the x-axis right here, right? And that point is, again, where cosine is 0. So that means where the x-coordinate is 0. Here the x-coordinate is -1 on the unit circle. And then here is where the x-coordinate is 0 again. Okay, so that's a 270-degree rotation to go from the initial side to the terminal side, or in other words, that's 3 pi over 2. And that looks about right, okay, because if pi is this point here and 2 pi is this point over here, then halfway between those two is where it crosses the x-axis. So that means we can put a dot right here at around 1.5 pi, 3 pi over 2. So that's 5 points. Let's hit the graph tool. There it goes. It makes the rest of the trig function. So if you're new to this topic, a lot of that was probably pretty confusing. Let's try out another graph, okay? Make this window bigger too. Let's pull this over here. Pull this over here. Same type of thing. Now we got 2 sine x. So the graph of sine, it actually starts at the origin when you don't mess with the x variable inside here, okay? Like if it said sine x plus pi, that would cause a horizontal shift. It wouldn't start at the origin. But since it's just 2 pi, that 2 only messes with the amplitude of the function. So that means its highest point is 2 and its lowest point is -2. And sine is different from cosine only in that it starts at the origin. So we start here, go up to the peak, go down to the valley, and then we should be repeating ourselves again at 2 pi. Just like with cosine, it has the same period. And so halfway between, that's -pi, that's where it should cross the x-axis. You could again find that by plugging in 0 in for y. If you solve this equation in radians, you're going to get x equals pi. So we got 2 x-intercepts. It crosses the x-axis at pi, crosses the x-axis at 2 pi, and then also at the origin. So there's 0, here's pi, here's 2 pi. We also need to make dots for the minima and maxima. So if this is 0 and if this is pi, then halfway between we should reach our little peak here. So pi over 2, halfway between those two. So here's where 0.5 pi is, pi over 2. And we're going to put the dot up here because we said the 2 changes our amplitude. It means 2 is our highest point. And then same thing over here, we got pi and 2 pi, so halfway between those two is 1.5 pi, or in other words, 3 pi over 2. And then again, the lowest point should be -2 on the graph, if I drew that right. So we're going to put a dot down here at -2, and there we got 5 coordinates. So see the sine wave happening. Now if you hit the graphing tool, it takes care of it. Let's do one more. So -3 pi over 2. So the negative sign is something we haven't done yet. Normally cosine, we said, looks like this. Starts at the peak of the amplitude, goes down. So the -3 pi over 2 just kind of inverts everything, okay? Now it's going to start at the bottom of the amplitude at -3 over 2. So here, if this is -1 and this is -2, then it's going to start here at -1.5. And then it's going to do the normal cosine wave. Goes up, down, and then we've reached 2 pi. We've started repeating ourselves again. Okay, here, let me draw that a little better, though, because we need a better idea of the graph to estimate those points. Okay, so -3 pi over 2, that's the amplitude. Because it's negative, that means we don't start at the top of our amplitude, we start at the bottom. So put a dot right here, and then at 2 pi, we should be back to this dot right here where we started on the y-axis. We should go up, oops, reach the peak of our amplitude, then come down, and then sinusoidal waves complete. We just keep repeating ourselves. Another 4 pi. We don't have to necessarily go that far for the graphing utility to work, but another full 2 pi distance. When we reach 4 pi, it should be repeating itself again. Okay, so to find the x-intercepts, find out where it crosses, the halfway point is right here. Between 0 and 2 pi, pi is the halfway distance. And then between 0 and pi over 2 should be that halfway distance. Between pi and 2 pi, 1.5 pi. So you can see it crosses the x-axis at pi over 2 and 1.5 pi. So we're going to put a dot at pi over 2, which is 0.5 pi. We're going to put a dot at 1.5 pi. And then we also said it's going to reach the bottom at -1.5, and over here at -1.5 again comes back down. And they also wanted the maxima, this point here, the highest part. So we said the amplitude's 1.5. It goes up to starts at -1.5, then climbs up to +1.5, then comes back down. Okay, so hopefully that helps. You can definitely message me if you still have questions.